I'm back with part 2. So in part 1, we were saying, we were talking about the F-35 and whether or not it could be hacked. And I said that if you look at a phone like an Apple phone, we have digital signatures on all of our software that comes from Apple. Every piece of software, the iOS, the app, everything. It's digitally signed, so it's impossible for somebody to make a fake version of iOS and try to load it onto your phone, because your phone has a signature, the Apple signature, burned into the phone, so it's not possible. But remember that hackers got into SolarWinds developers' computers. They put viruses into the source code, and then SolarWinds didn't know that, so they digitally signed their software, and then they sent it out, and people in the government downloaded the software, and their computers checked the digital signature on the SolarWinds application, and it seemed legitimate, and then they all ended up with viruses. Well, not viruses, but they all ended up with backdoors, like 20,000 computers, and then hackers got in. So now this plane, when you think of Windows can be slow. So even the best computer, you get periods where it slows down, or it crashes, or it gets overloaded because there's too many things open at once. So Windows is not really the best operating system for a plane because it'll crash. Instead, they use what's called a real-time operating system, which is a operating system that doesn't crash. It just doesn't. It's designed to run like 24/7 without slowing down. And the one that they use is made by another company called Green Hills Software. So Green Hills Software has designed this operating system so that the different things that you're running on it, like apps, aren't allowed to talk to each other directly, which could allow them to damage different parts of the operating system or the plane. So it's actually a very complicated system. We've got all kinds of spaces and middleware. By middleware, we've got like all the different possible peripherals that can talk to the operating system. So like USB devices and Wi-Fi and audio, and obviously we've got fiber channel. We've got a lot of specialized functions on this plane, but essentially you can think of this plane as like a computer with a whole bunch of USB stuff plugged in, but instead of like a speaker and a mouse and a microphone and a webcam, you've got a radar and antennas, and you've got touch screens in the cockpit. But literally all this stuff has to talk to each other all at the same time and never ever crash or slow down. And so that's where the real-time operating system comes in. Now, of course, this stuff needs software updates all the time, and it's not very secure if the apps themselves are not secure. But now if we look at the software on the F-35, it actually, what they did was they took the software from the F-22, which was written in the 1980s, and that's the software that they started with, and it was written in a language called ADA 83, and this is much older than I am. And then they added C++, which, when did that come out? A while ago. But basically, then the C++ and the ADA code resulted in version 1A and 1B, which gave us some basic software, but then they said, okay, we're going to improve the software, so then they came out with version 2A and 2B, and then 3I and 3F, which was a refresh, and then now they're working on block 4, which is much more advanced software for the planes. So that means you could build the plane and you could write the basic software and then sell the plane, and then come back later and say, you know what, I'm going to upgrade the software on my plane on the newer version. So the 2022 model has version 3, but the 2025 model has version 4, and then you could take the 2023 model or whatever, and you could change the software. And if you change the software, that gives you like more advanced features, or you could add components that you couldn't add before, like AI or whatever you're adding to the plane. But it doesn't really matter. But you have a huge problem here, because when you think about it, you've got vulnerabilities in the operating system, and you think you have 16 million lines of code on the software, that the app that runs on top of the operating system. And then remember from a previous video, we have components from like 10 major players in the defense industry, including like Raytheon and BAE and Harris. And so all those people make pieces that have to talk to each other so the plane can work. Because we got a guy who makes the weapons, and the guy who makes the radar, and the guy who makes this and that, and they all gotta talk. So that means everybody needs like either an API or they need access to the source code. And those people have buy their components from other manufacturers, so they need to talk too. And there's all kinds of sub manufacturers. So there's like 150 different manufacturers that have access to the code. And then you've got code running on all these little chips that doesn't form part of the main system. It just does inputs and outputs, but it's like a black box, and you got like thousands of these little things all over the plane, and a lot of them were made in China, and there's no way to read the code on every little chip, and even if you could, there's no way to update it. So imagine you're building a plane, you'd have to like somehow plug into and integrate to a little black microchip and try to read the code that's on it. It's literally impossible. And to try to do that, to try to do like quality control on every single chip's impossible. Now on top of that, you think about it, it's been 10 years and there's been like 20,000 people who have access to this code. And so as the planes progress, what happens is you have a manufacturer who's says, "Oh, I found a way to write the code better." So they release a new version of their code that goes on their chip. And so now you have a new version of the chip on a new version of the plane compared. So chip number 1 has a newer version of code, and chip number 2 might have the original version. And so now you have all these planes, and literally every plane has a different combination of software, because you've got 4 main versions of the main software, plus you've got probably 5 or 10 versions of the software on each subcomponent, and you never know what you're going to get. And so it's extremely crazy to try to update this, and I don't think there's anything digitally signed, so it's not possible to verify what's what. And I'm telling you that because people think, okay, this plane takes off and lands on its own like it's just a plane, but it's not, because what you actually need for every plane is like literally 3 racks of equipment which weigh like 900 pounds, and this equipment actually close to 1,000 pounds. They call this the Autonomic Logistics Information System, and they put autonomic in quotes because this thing was supposed to work like an iPhone, but it didn't work. And every plane needs basically these are the size of refrigerators full of computer hardware, and this is what supports the mission. So the biggest problem with this is supposed to talk to the plane while it's in the air, and it's got unclassified data like parts, maintenance, the crew, and it's got classified data like mission planning. And the classified data and the unclassified data are supposed to travel on the same network, but they're supposed to be separated, and they're supposed to stay secure, which isn't possible. But one of the biggest problems was, like, this plane was supposed to, for example, monitor literally everything that's going on the plane and send it back to the server, and then the server could automatically figure out, okay, this plane, something, a wing tip wore out, or something wore out on the plane, and it needs this part, an engine air filter, let's say, and the plane's in Germany, or it's in Toronto, or wherever it is. So then they could get parts to that plane automatically really quickly and get a maintenance guy and create a work order and fix the plane, because planes need maintenance. But none of this ever worked properly, and then it turns out that all of this, it doesn't matter where you are in the world, bought this, you need the servers, and they all send their data back to Lockheed. And so now they decided that they're switching over to a new system called Odin, which is really supposed to work like your iPhone, and they swear that it's going to work, and it's going to be cloud-based, and it's got like 65 apps, and it needs way less computer hardware. Basically, one big special server and one UPS. That's all you need, and then you got some network equipment. So this is only like 4 rack units tall, like computer-wise. So it's like 2 really massive briefcases, basically. And this thing's supposed to communicate on the internet and then send like data out to all these people, warehouses, like customer support, logistics, and it also does classified and unclassified data on the same system. But this is a huge vulnerability, because now anybody, after 10 years in the making, there's probably literally every country has put a backdoor into this thing, and it's practically impossible to keep a system this size fully secure, especially since it's exposed to the internet. So if you have any questions, please post a comment. But before that, let's summarize. So, why is this plane not secure? Well, number one, there's a trillion components from literally every defense contractor that ever existed, and they all have to try and talk to each other. Radar, antennas, engines, and then fiber channel switches, and then every component has aftermarket, has subcomponents that are, some of them are made in China, and then there's engines, and then there's aftermarket components that you can add that also talk to the plane. And so everything has a chip, and there's like 10,000 chips on average in the plane, and every chip has software, and a lot of these chips were made in China, and it's impossible to know what the source code is on every single chip. So and then there's no digital signatures, so anybody could get in and pull whatever software they want, backdoor, and the software keeps changing, and we don't know, because there's so many components and subcomponents and software that every plane literally has different software, and there's a ton of server hardware needed to run every plane, and it runs classified and unclassified data on the same system, and that's been causing a headache. And when you buy the plane, your server reports back to Lockheed with all the details, and so it doesn't really matter whether they can have a kill switch or not, because there's so many security holes potential that it doesn't really matter. So if you have any questions, please post a comment. Thank you.